Exercise 12C-3 Recursion. In our previous video, we were examining the idea of transition matrices. In other words, if I have one state of affairs on one day, what's the likelihood that it will change the next day? Well, we were finding out if it was raining or sunny, or whether or not we're studying maths or English, whatever the case might be, that's what we use transition matrices for. But now we want to know, what if we were to continue this pattern? So if we want to find out not only just what is the likelihood of if it's going to be sunny the next day, but what about the day after that? Or the day after that, or the day after that, or so on. And this is when you can possibly hazard a guess just by the attitude of the language. This is very much a recurrence relation scenario. And so now we need to be able to use matrices and transition matrices to do recurrence relations. So you need three things. You need an initial state matrix. And what is that when it's at home? Well, an initial state matrix is the original numbers that you had for each of the state of affairs. So, for example, in our previous video and things like that, we were looking at that we had 100 students doing maths. We had 76 students doing English. So, and then we did some multiplication. Well, this is exactly the same sort of state of affairs here. The transition matrix you're already familiar with. The number of transitions literally just means how many times do I need to keep doing this? So is it on day 5? Is it on week 7? And that kind of thing. There are some times where we have to work backwards, and we'll get to that sort of business a little bit later. But those are the three things you need essentially for any recurrence relation with matrices. We usually write them in the format you can see there. We use S's generally. So S naught is equal to whatever the initial matrix is. And then we have Sn plus 1 is the transition matrix times by Sn, where Sn is each of the iterations. And so if that's how you write the recurrence relation, if you're asked to write the rule, then it's Sn equals the transition matrix to the power of n times by S naught. If you see the phrase steady state solution, that's a very complicated way of just saying, what's it going to happen forever? Like, what if I was to do 50 weeks time or 50 years time, what's it going to be? And it is, if you want the real proper definition, it's the value, your final value, where no matter how many times you multiply by the transition matrix, the final result doesn't change. In other words, when the decimals stop rounding, and you'll see what I mean when we get to that. As soon as we get to the point where the multiplications do not change the final answer, that's the steady state solution. In my personal opinion, I usually just make n equals 50 and bang, that's always going to be the final answer. So that's my short and quick way of getting a steady state solution. So in this scenario, we're trying to find the attendance habits at a gym. Let's get this into a matrix. We have three categories: at least 3 times, 1 or 2 times, or not at all. So let's go for at least 3 times, which is this first one. Those who will go for at least 3 times again, it's going to be 0.6. 30% of the members who are at least 3 times to 1 or 2 times. So that means the final column is going to have to be 0.1 because I have to add up to 1. The next one, the 1 or 2 times, I'm just going to do different colors to separate. 80% of the members who will attend 1 or 2 times will attend 1 or 2 times the next week, so 0.8. 10% of the members who will attend 1 or 2 times a week will attend at least 3 times the next week. We've got 30% of the members who do not attend will not attend the following week. So I'll put that as 0.3. 40% of the members who do not attend will attend once or twice, which means by process of elimination, that's going to be 0.3. It's also, you'll notice though, it says the word proportions. That just, consider that to mean just write as decimals. Surveying 720 members predicted that 131 members will attend at least 3 times, 386 will attend 1 or 2 times, and 203 will not attend. Write this information in the form of an initial state matrix S naught. So S naught is equal to snort, if you will. We want 131, 386, and 203. Remember, we want the verticals to be in the same order as going from left to right, up to down. Now, the one thing, when we do calculations, just so you know, we'll get this 720 will be very important. In much the same way that a transition matrix cannot, all the columns must add up to 1. When we find out all the other iterations, the final answers must always add up to 720 as per the scenario, and you'll see what I mean by that in a moment. Assuming these predictions were correct and S1 represents the number attending at the end of week 1, calculate how many members attended at least 3 times, 1 or 2 times, or did not attend at the end of week 1. So we're going to do a multiplication. So we're going to take the original transition matrix. So we're going to go 0.6, 0.3. Multiply it by that initial state matrix. So there's our multiplication. Now what we need to do is to make sure that we round correctly, because the final answers, when we round them, should still add up to 720. So I would say it's 107. I'll get a different color here. I'll get my blue here. So 178 members attended at least 3 times, 429 1 or 2 times, and 113 in this case did not attend. And what I'm just going to do is very quickly just check to make sure that I haven't made a derp. 178 plus 429 plus 113, bang, it gets me 720. So what we want to do is make sure it's correct. Now, a reason why I was suggesting that we have to be careful is that when you're doing some multiplications like this, you might end up with some of them being like 178.45 or something like that, where it's sort of in the middle. That's the biggest danger. If you end up with getting values that are in there, triple check that whatever you rounded is correct, such that the column should still add up to the total amount that there was to begin with. So we can't have more members. More members can't have turned up. Members kind of vanished into the ether. We are assuming in this case that no members will disappear, that kind of thing. D, how many members are expected to attend at least 3 times at the end of week 5? All right, so what we're going to do is we need to now find out if I was to keep multiplying, so if I was to take that 178.1, that 429.3, and that 112.6, if I was to get the transition matrix and times it by that, that will get me the next week. That would get me S2. And then if I did it again, that'll be S3. So that's a very long and complicated process, so we may as well just streamline it. And we'll take our original transition matrix, like so. And this time we'll do the power of 5. So all I need to do is go back to my CAS, take that original number, do it to the power of 5. So I'll just click back up at the top and arrange that next to that original transition matrix. And then we get our answers here. So this rounds up to 181. 449 and 90. And again, I just want to check that that all adds up to 720, and it does. So we want just the ones that have at least 3 times. 181 members attend at least 3 times. Again, if you just chuck the final matrix is your answer without any context, an examiner will mark that wrong. E, of the 720 members of the gymnasium, determine in the long term the number of members who are expected to attend at least 3 times in a particular week. So steady state solution, that means that all we need to do is we need to find out or keep this going. And usually what I would do here is I would simply just take the original transition matrix. This time just do it to the power of 50. And this should get you the steady state solution. added them together, still equals to 720. So at least 3 times we have 180 members.